Today, I'll address some of the basic concerns many of you have shared when considering building your first DIY electronics project. I'll talk about a few of the most common trepidations, including safety, having no or very limited electronic circuit or coding knowledge, and show you how you can start by creating a few basic sensors with no special tools, no soldering, or by writing any code, and then show you how you can slowly add tools and components to advance your skills and take your projects to the next level. Hi, and welcome to Resin Chem Tech. Now, most of the things I do here on my channel focus on beginner or maybe intermediate level DIY projects. And while it makes my videos much longer than many others, I do always try to explain the why as well as the how when it comes to my projects. Despite that, I've heard from many of you out there that have never built your own DIY project and are a little bit hesitant to try. Maybe you watched one of my videos or another YouTube channel where there are things like benchtop power supplies and oscilloscopes or the dreaded soldering iron, and decide that these projects are simply beyond your ability, desire, or budget. So today I'm going to address some of the most common concerns and fears that I've heard, and then I'm going to show you how you can build some simple devices like sensors and controllers with absolutely no tools at all and for just a few dollars a piece. Then I'll show you some of the basic tools and components that I use with almost all my projects that you can slowly add to your arsenal as you gain more experience. And I'll include some examples of what can be done at each of those levels as I go along. And yes, I'm even going to get into some very basic soldering skills towards the end of this video when you feel you're ready. As always, the video description will have links to everything I show, along with a link to a written guide that will have all of the parts and more information. One of the most common things I hear from people just looking to get started is that they've never worked with electricity or electrical circuits, and that causes a little bit of trepidation. If you're building projects or you're using something like microcontrollers, like maybe the ESP family, Arduino, or even a Raspberry Pi, you're generally going to be working with very low voltage, usually 5 volts or 3.3 volts. In addition, unless you're building something like a large LED display, you're also going to be looking at very low current. Maybe 1 or 2 amps, but in most cases for things like sensors and the ESP boards, you're talking about just milliamps. So you're talking about something that is about the equivalent of working with 3 AA batteries. But unless you are building a battery-powered display, you're probably going to be using some kind of AC adapter or transformer to provide your voltage to your board. A lot of times this can just be something like a small wall wart with a USB adapter, or for the ESP boards, a lot of times you can get away with something simple like a cell phone charger and a USB cable to power your boards. But in some cases, depending upon your project, you may need or want to buy a little beefier power supply like this 5 volt 10 amp power supply I have here. Maybe it's just because you don't want that big old wall wart and you want a standard AC plug. Now this is still going to take a 120 volt AC here in the US, but it's still only going to be putting 5 volts output here at the business end. If you do end up buying a power supply, be sure that you're buying quality power supplies that have built-in things like overload, overtemperature, and short circuit protection. That way, if you do make a mistake, it adds an extra level of safety. Now, I don't recommend you do this unless you truly want to test your power supply, but I've got my 2 wires here coming out, my positive and my ground, and I'm going to intentionally create a short circuit here and keep an eye on this light. Okay, notice how that light went out? When I created a short circuit, that killed the power supply. As soon as I correct it, the power supply is energized once again. Sometimes, depending on the power supply, you may have to cycle the power, unplug it, plug it back in again, but this adds an extra layer of safety in case you inadvertently do create a short circuit or overload the power supply. In most cases, as long as you're using some common sense, the worst that will happen is you might fry a sensor or damage a component. I've done that more times than I can count, and I even show some of my own basic mistakes in a few of my videos. Along the way, and as part of the learning process, you might occasionally create a little magic smoke and be out a couple of dollars and a few minutes of your time, but rarely will any other damage or injury occur. Just observe some basic safety practices. Wear eye protection or use gloves if working with sharp edges or maybe doing something where an item or a piece may fly or splatter. But unless you're working with mains household power, like installing a smart light switch or maybe a very large LED installation that has high current, most of these projects are pretty safe and pose little risk. Okay, hopefully with that fear put to rest that something isn't going to just suddenly explode or blow up in your face, let's move on to taking a look at how you can build some basic sensors to get started with absolutely no tools and no soldering required. Using something as simple as a cell phone charger, a USB cable, or microcontroller, and just a few DuPont jumpers, we can build all sorts of sensors like motion, distance, temperature, humidity, light level, or even do something like attach a microphone. And of course, there's all sorts of variations of all these components. Even the charger, if you don't want to use one of your cell phone chargers, or maybe this is going to stick out from the wall too far, you can simply pick up a different USB charger. I happen to like this one because it's slim, doesn't stick out from the wall, and it actually has two USB ports, each one capable of providing 3 amps, so I could technically power 2 different devices off this one charger. And as I mentioned earlier, there are all sorts of different types of microcontrollers, so let's briefly talk about the choice of a microcontroller. As mentioned, there are many types of controllers, including the Arduino and Raspberry Pi families, but one of the most common and lowest cost options for DIY projects is the ESP family of microcontrollers. There is the original 10-year-old ESP8266 series and the new, more powerful ESP32 series. In many cases, like the simple sensor projects I'm going to show, either one will work just fine. But in some cases, if you're building or attempting to duplicate someone else's project, a particular ESP board may be required, so always check that project's documentation. In the past, unless you need the extra processing power or something like Bluetooth, which the ESP32 adds, I always recommended the ESP8266 due to its lower cost and slightly smaller size. But the cost difference has gotten significantly smaller, and Espressif, the manufacturer of these chips, only guarantees 12 years of support for their chips, and that will be in about 1.5 years for the original ESP8266, so I now generally recommend the ESP32 for any newer projects. But even within a family like the ESP32, the chip itself can be mounted on different shapes and sizes of development boards with different connectors and number of pins. Now do note that some versions do not have the pins attached, which would require you to solder. I'll talk a little bit more about size later, but for now I'm going to be using a standard node MCU style ESP32 that comes with the pins pre-attached and has a micro USB port for both programming and powering the board. There are a few things we need to find out before we connect a sensor to our ESP board. First, all of these sensors require power, so we need to know what is the working voltage for each type of sensor. Some may be 5 volts, some may be 3.3 volts, some may work on a range of voltages. Our ESP board usually has at least one, sometimes more, power pins, labeled either 5 volts or VIN for the 5 volt and a 3V3 for 3.3 volts. So when we're powering this by USB, we have both 5 volts and 3.3 volts available to power our peripherals. You'll also see one or more ground connections, and if there are more than one, it really doesn't matter which ground connection you use because they're all connected together internally. The next thing we need to know the pinouts, or which of these pins connect to what. And for most of your sensors, you're going to find that they have either 3 or 4 pins, although there may be other types of sensors that have 5 or more pins, or when you start moving up into something like displays, there may be multiple pins, but the process is generally going to be the same. 2 of those pins are going to be for your power and your ground, and any remaining pins are going to be data pins. And those data pins we're going to connect back to a GPIO, or general purpose input-output pin, on our ESP32. So you might ask, how do you know which GPIO pin to use? Well, let's start out by taking a look and connecting up our DHT22 temperature and humidity sensor. Looking at the specs for the DHT22, we see it has a working voltage of 3.3 to 5.5 volts. That means we can power this off of our 5 volt or our 3.3 volt pin. It really doesn't matter. We look closely, it's a little hard to see here on the camera, but these pins are marked. Our pin here on the left is our positive voltage. The pin on the far right is our negative or our ground, and the center pin is labeled out, which is actually our data pin. But which GPIO pin do you select? Now, the ESP32 has much more flexibility in terms of GPIO pin usage than the ESP8266, which had a few more restrictions, but that doesn't necessarily mean you can use any pin that you want for any purpose. So what I like to do when I'm looking for a GPIO pin that will work is I like to go to this site by Random Nerd Tutorials, and I'll leave a link to this down in the video description. It gives you all the descriptions of the different GPIO pins on the ESP32, but really the handiest part is this chart right down here that tells you appropriate GPIO pins to use for input or output. In this case, all of our sensors are going to be input, so I can look for anything, any GPIO pin is labeled with a green OK, and that is perfectly fine to use for the data pins for our sensors. For this particular case, I'm going to choose GPIO 27 for our DHT22 temperature and humidity sensor, but really I could use any of these pins that are marked with OK. There's a good possibility that when you first start out, you may be duplicating someone else's project, and they may include wiring diagrams. If you see something that looks like this, some kind of wiring schematic with a whole bunch of electrical symbols, while it's good to learn how to read these, you don't necessarily need this as a start. If you do a little bit of searching, you can probably find some simplified diagrams. For all of my projects where I include a written guide along with the video, I try to use these simplified diagrams that actually show you the components and how they're connected together. So using this, we're going to go ahead and make our connections here. So I simply need to connect to my 5-volt pin here. I'm going to connect to my ground pin next to it. So you see that labeled on the top. And then I said I was going to use D27, which is going to be a little hard to see, this pin. And all I've got to do is connect to the corresponding pins on the sensor itself. Again, if you're duplicating someone else's project, they may require certain GPIO pins to be used, and you'll need to follow that. But it's also, again, important to understand why you're doing it the way you're doing it so that eventually you can create your own projects. So that pretty much creates our temperature humidity sensor, except we're missing one thing, and that is the firmware or the code on this ESP chip to actually make it work. Another common stumbling block when first starting out is the installation of the firmware or the code that goes on your microcontroller. Now, you may initially be trying to recreate something you've seen here on YouTube or maybe in a web article somewhere, and it might include a lot of code blocks or a long listing of code, and as a non-programmer, you might think that there's no way that you can recreate this. But don't give up, as there are a lot of ways to easily install firmware on your microcontroller that involve little or no actual writing of code. And this has gotten a lot easier than it was just a couple of years ago. Many firmware options now offer point-and-click installations right through your web browser. For example, Tasmoda and the ever-popular WLED for controlling your LED lights now have websites where you simply connect your controller to the USB port on your computer, go to a website, and point and click to install the firmware. Many will even actually walk you through entering your Wi-Fi credentials to mount your controller onto your Wi-Fi. Not a single line of code needed. These sites have more information for actually installing their firmware, and you can check that out when you're ready. Other developers may make something like a binary or .bin file available. All you need to do is download that binary file and then use a desktop utility like Node MCU Pi Flasher or ESPHome Flasher to install that directly on your ESP board. Again, all point and click, and not a single line of code is required. But what if you can't find pre-built code or firmware for your project, like for our little temperature humidity sensor? Well, one of the easiest to use options in this case is ESPHome. You can create your own firmware using ESPHome, in most cases by just simply copying and pasting a little bit of code from the ESPHome website. This works well, at least for some of these basic and less complex projects that you might be starting out with. Now, ESPHome is now owned by the Open Home Foundation, which also owns Home Assistant. So as you might expect, ESPHome has very tight integration with Home Assistant. But it's not absolutely necessary to have Home Assistant to use ESPHome. It is possible to build firmware using just ESPHome. So let's take a look at using ESPHome to build firmware for our simple little temperature humidity project. Now, this really isn't meant to be an ESPHome tutorial. I'm just going to show you how easy it is to be able to create and load the firmware onto your ESP board for something like this temperature and humidity sensor without really writing any code. And yes, I am operating under Home Assistant here, but you can use ESPHome independently of Home Assistant, and I'll leave a link down below for more information on that if you're interested. We're simply going to create a new device. Here's some information, and again, I could actually open ESPHome Web. This is a site you would go to if you wanted to directly install ESPHome onto your device and be able to access it wirelessly without using Home Assistant. And I'm going to go ahead and use the version here within Home Assistant. So I'm just going to click Continue. I need to give my device a name. I'm just going to call this Sensor Test. Now I need to select my board. Again, it's important here that you select the right type of board. Note that the ESP32 now has a number of different series. I'm just using a standard ESP32, so that's all I really need to do. And now I would again have the option to go ahead and install this, but I'm going to skip it so we can go ahead and add the information for our sensor. So here we can see our sensor test. It's offline because we haven't actually uploaded anything to the ESP board yet, but we can click Edit, take a look to see what's in this file, and add information for our sensor. ESPHome has automatically created all this information for you, including connecting it to your Wi-Fi and information for integrating it into Home Assistant if you want to do that down the road. So we don't need to do any of that. We just need to come down here to the bottom of the file and add information for our sensor. But how do you know what information to put in here? This is written in YAML, and if you don't know YAML, how do you know what to add for our temperature and humidity sensor? Well, it's actually pretty easy using the ESPHome website. Now, the ESPHome website contains tons of useful information and a lot of examples, but it can be a little difficult to find information for a specific device, and the search feature here does leave a little bit to be desired. So what I found to be a little bit easier to do is actually jump over to Google, type in ESPHome and the particular device you're looking for. In this case, I'm looking for the DHT22. Often, the very first thing that's going to pop up is the actual ESPHome documentation. So we'll go ahead and select that. And here we can see all the information for the DHT series of temperature and humidity sensors. And it supports all these different ones. And here's our DHT22 that we're using. So we can come down here, and here's actually going to show us the example YAML that we can simply copy and paste into our ESPHome node and then modify it for our particular use. Notice that the information will also contain information about optional parameters that you can include in here. But for now, we're just going to take the default example here. We're going to copy that, and we're going to bounce back over to our ESPHome, find our sensor test, come down here to the bottom. The only thing you want to do is make sure you're fully left justified here, and we will simply paste that in there. Now, there are a couple of things we have to change. One is the pin. Remember that we were using GPIO 27, and here it has a D2. Some boards will actually have an alias for their pins, but to be on the safe side, you can always enter in GPIO and the actual number. You can also just use the number itself, but I do like to use the GPIO in front of it. Now all we have to do optionally is change these names if we want them to be called something different. I'm just going to leave them as living room temperature, and an optional update interval, how often this value is going to update. Just for the purposes of this so that we can see it, I'm going to change that to 3 seconds instead of 60. Now all we have to do is save our file. Once the file has been saved, we're just about ready to install, but the one thing I like to do first is I like to go ahead and click these 3 dots and select Validate. That will actually check your YAML to make sure you didn't make some kind of mistake in terms of that copying and pasting, like an indent, or you misspelled something. As long as you see this green check mark, we're ready to go ahead and install. At this point, we do need to connect our ESP board to the computer, so we will make sure that we're using a data capable USB cable, not just a charging cable. Plug one end into the ESP board and the other end into the computer. At this point, with our board connected, we're now ready to do the actual installation. We can come over to the 3 dots and choose Install. Now, notice that after the first time we install ESPHome, we can do everything wirelessly, but for the very first time, we have to select this option that is plugged into this particular computer. So we'll select that, and it's going to prepare a download. Now, the first time it does that, it may take a while because behind the scenes, it's actually compiling all this code into an Arduino bin or binary file. And if you're not running over HTTPS, which I'm not, you're going to come up with this message saying not all requirements are currently met. But we have this option to first download the project. You click that, it's going to prompt you to download the bin file, and as you can see, I've already done that here. Once that's done, we can open ESPHome Web. Now we're going to connect to our device. So we'll click this button, and it's going to pop up a series of COM ports. Now it should be pretty obvious that if it has one here that's marked paired, that is your ESP board. If you don't know for sure, you can unplug your board, see which port disappears, then replug it, and you'll know which COM port to select. If you don't see a COM port pop up, notice that you may not have a driver installed for your particular computer, and there's information here on how to install that driver. Now I'm going to go ahead and select the port that I know my ESP is connected to, and I'm going to select Connect. Now I have an option to install, and I select that bin file, open that, and then just simply click Install. This will take a little bit of time while it goes ahead and prepares the board. It says it's going to take about 2 minutes. I'm going to zip through this and come back when the install is done. Okay, the installation is done, so I can simply close this. At this point, I can go ahead and disconnect this from the computer if desired and go ahead and plug it into its normal power source. Now, you might have noticed when I flashed this, I did not have the sensor attached. It's fine to go ahead and do your initial flash without anything attached to your board, but obviously you're not going to need to connect your sensor to get any kind of valid readings. So I've reconnected my sensor and I've plugged it into a USB power source that I'm going to go ahead and plug into an AC outlet. Okay, at this point we're powered on. We can go back over to ESPHome. Now back over in ESPHome, we can see that our sensor test is now online. And if we take a look at the actual logs, we're going to see it connect to the Wi-Fi. And right now we can see that we're getting valid temperature and humidity readings. It was really that easy to create this sensor. I can now take this sensor and either integrate it into Home Assistant if I'm using it there, or I could even do something like attach a display to it to be able to display the temperature and humidity right here locally on the same device. What if we want to create something like a distance sensor instead of a temperature and humidity sensor? Well, we're going to follow the same exact process. And in fact, I'm going to reuse the same ESP32 board and the same ESPHome node. Looking at our description for the HCSR04, we can see this is a 5-volt device, so we're going to need to use 5 volts to power it. And we can see the pinouts right here. We've got our 5 volts and our ground, and we actually have 2 data pins in this case. We have a trigger, which is going to be an output pin from our ESP32, and the echo, which will be an input pin. So from there, we go out, we select a couple of appropriate GPIO pins. In this case, I'm choosing GPIO 25 for my input and GPIO 26 for my output. From there, we simply wire it up. And once we've got it all wired up, remember this already has ESPHome on it from our temperature humidity sensor. So we don't need to reflash the initial ESPHome. We can go ahead and power this on, and all we've got to do is go over to ESPHome and replace the configuration from that temperature humidity sensor with the configuration for this distance sensor. Once again, I'm going to come over to Google. I'm going to search ESPHome and HCSR04, which is our ultrasonic sensor. It's going to pop up as our first option here. We're going to select that and come down here, and once again, here's our code. So we're going to copy that, but there is one thing I want to note here. By default, this is only, again, going to update once per minute or once every 60 seconds. So I'm going to want to change that update interval. But now that I've got this copied, I can go over to ESPHome. In ESPHome, I'm going to find my sensor test. Here it is. I'm just going to edit that. What I'm going to do is I'm just going to remove this previous sensor, which was our temperature humidity sensor, and paste in the code for the ultrasonic sensor. Now remember that default update interval was 60 seconds, and I do want to change that. So I'm going to select update interval and say 1 second on that. Now I also need to update my GPIO pins. So I update the GPIO pins to GPIO 25 and 26 for my echo and trigger pins. I could optionally change the name here as well, but now I can click save and I can click install. Once again, I can do this wirelessly since it already has ESPHome on it. So we'll start that install. This will take just a couple of minutes to compile, and we'll come back as soon as it's done. And once the upload is complete, we can go back in here, we can open these logs, and we can see we're getting distances. And if I put my hand over that, you'll notice how that distance is changing. Again, this is being reported in meters. I could easily make that inches or centimeters if desired. But just by simply making that small change of swapping out the sensors, updating the ESPHome code, we went from a temperature humidity sensor to an ultrasonic sensor, and any other types of sensors would be done in very much the same way. So up to this point, we've been able to create a lot of basic sensors with just some DuPont jumpers. But to be honest, this probably isn't the best configuration for trying to keep something permanently or to install somewhere. For one thing, these DuPont jumpers could come loose very easily and just real no good way to mount that. Or what happens if you want to start adding multiple sensors to your project? Now the ESP32 is perfectly capable of handling more than one sensor, but let's say you've got a couple of sensors that both require 5 volts. Well, your ESP board only has one 5-volt pin. So this is where you need to start thinking about adding some simple components and tools to your kit to be able to make your projects better. And the very first one is the simple little breadboard. So For the rest of this video, I'm going to quickly move through some tools and components you may wish to slowly add to your inventory to help make your projects better or to allow you to build more complex projects as your skills grow. Again, the links to everything that I show can be found down in the video description, and with Prime Days right around the corner, it might not be a bad time to start thinking about growing your stockpile of components and parts. One of the first things you may wish to add to your tool set are some simple breadboards. If you've not used a breadboard before, it contains a series of rows and columns that are electrically connected and makes it easy to mount and wire your components together. If we take a look at this electro cookie, which is really the same thing as a breadboard, we can see how all these rows and columns are connected together. Here at the top and the bottom on each, you have all of the rows that are connected together, and these are great for creating power rails. So remember we talked about you might want to connect multiple sensors that need 5 volts, but you only have one 5-volt pin. Well, by connecting our 5-volt pin up here with the ground, we now have a whole series of 5-volt and ground connections for connecting multiple sensors. Down here, we could do the same thing with 3.3 volts. And of course, here in the center, all of the columns are connected together on each half of the breadboard. And this is where we can mount our components and make our wiring connections. Now note, if this isn't big enough, you can always move up to a full-size breadboard, and if you need even more space, you can use these tabs on the side to connect multiple breadboards together and build how much ever space you need for your project. But there is one thing I want to mention regarding using the ESP32 with breadboards. The standard 30-pin ESP32 dev board I've been using previously is actually slightly too wide to fit on a breadboard and leave a row of pins on each side for connecting. However, you can buy narrow versions of the ESP32. This is a 38-pin version that, when mounted on the breadboard, actually does leave a row of holes for connecting on each side. So if you're going to be using the ESP32 with a breadboard, make sure you buy one that's either labeled as narrow or breadboard friendly. So let's take a look at our original distance sensor and moving this over and creating a breadboard version. Of course, you can continue to use the breadboard with these DuPont jumpers, and that might be fine for your initial testing, but we really haven't gained much by adding a breadboard. Where a breadboard comes in handy is when we start to use something like these breadboard jumpers, and this will allow us to mount everything on the breadboard and kind of get rid of these external wires that are hanging out. Using the breadboard jumpers, I made the same exact electrical connections. The difference is now I don't have any dangling wires out there, and I really have a kind of a self-contained unit that might make it a little bit easier to mount somewhere. In addition, since I've created power rails here, I'm able to extend the use of my 5-volt and 3.3-volt pin. I can easily come in here and add my temperature and humidity sensor to this same ESP board. And if you were curious about how this would work in ESPHome, where before we replaced one sensor definition with another, well, in this case, we would just put both sensor definitions under our sensor integration. In this case, we now have a temperature, humidity, and distance sensor. Not quite sure where you would use something like that, but it gives you an idea how you can mix and match different types of sensors with a single ESP board. And again, remember, if things start to get a little bit too crowded on there, you can always move up to a bigger size breadboard. Now let's take a look at some basic tools and components you may need sooner rather than later. Now, if you happen to have large fingers or any kind of issues with dexterity, it can sometimes be really hard to try to get these jumpers in the right spot, even on a breadboard. So one thing I've found invaluable in my tool set is a set of these tweezers. They come in all different shapes and sizes, and I'm surprised at how often I actually reach for these to use them for a lot of different projects. And to be honest, they're really great for removing splinters as well. At some point, you're going to need to add some of your own wiring, and I recommend buying a small assortment of different gauges in both stranded and solid. Solid is nice in situations where, for example, you can't insert stranded wire into a breadboard, or situations where you may be building something you want the wire to maintain its shape. Again, you don't have to buy thousands of feet of every possible gauge. A box like this of assorted colors will cost you around 10 to 15 bucks, and there's like 32 feet on each spool, and that will last you a very long time. If you are just starting out and you're dealing with low current projects, I would maybe recommend you start out with 18 and 20 gauge of both stranded and solid. Of course, you're going to need a way to cut and strip that wire, and there are a whole assortment of different types of wire strippers and wire cutters out there. This is one of the most basic. However, with this one, you do need to be aware that you're selecting the proper gauge and type, such as solid or stranded. So that way, when you put your wire in here and you strip it, you're not tearing off any strands or gouging your solid core wire. A slightly more expensive option are strippers like this, and the nice thing about this, it does have a stop or a guide in here. So when you insert this in here and you strip your wire, it will always give you a consistent strip length. And do note that some of these often have other things like an integrated cutter and a crimper for terminals. At some point, you're probably going to need to join sections of wire together, and while you can use a wire nut, I really like to use these Wago lever nuts. These can be used for temporary or even permanent installations. Very easy to use is simply insert your stripped wire, and these are rated to handle anything from 12 to 24 gauge solid or stranded wire. You simply snap those into place and you have a nice solid connection. It won't easily come apart. And while I don't recommend it for a permanent installation, at least for your prototyping or breadboard or bench testing, you can even take something like your DuPont jumper, insert that into here, lock that down, and when you're done, simply take it back apart. And these come in 2, 3, and even 5 connector versions for joining multiple runs of wire together. Of course, there are many other ways. You could even use something like these alligator clips, although I definitely don't recommend these for permanent installations. And when you start getting more complex designs, it's really easy for these to inadvertently come in contact to each other and create a short or other undesired consequences. So I do like to use these lever nuts for most of my temporary and a lot of times even permanent connections. And because so many people can't or don't want to learn to solder, if you do a little bit of searching, odds are you'll find some sort of part out there that will allow you to connect your components together. While I'm not a fan of these actually allow you to attach wires to your LED strip without doing any soldering. You can also get them to connect 2 LED strips directly together. So if you're not quite ready to learn how to solder, do a little searching and odds are you can find some kind of connector out there. Sooner or later, you're probably going to need some precision screwdriver bits. You may have some screwdrivers around the house. This particular kit I really like because it contains very small sizes of nearly every kind of screw you can think of. This particular kit also comes with some extra tweezers, some spudgers, and some other miscellaneous tools that make it really handy for working on small electronic projects. And one final thing I like to consider part of the beginner's toolkit is a multimeter. Now you might be thinking, whoa, wait a minute. When we started this, you said that this was going to be for someone with no electronics experience whatsoever. Well, you can certainly buy simpler versions of this, but really you're only going to want to use this initially for 2 features. First is checking voltages. You want to be able to easily check and assure that any power supplies that you have is sending or any devices are receiving the voltage that you are expecting. And the second is to check continuity or check to make sure you have a valid connection between components where you think that you should. Now, a multimeter is not something you have to have right off the bat, but you will find it invaluable to troubleshoot first time you have a device that isn't working as expected. With just the basic tools and components I've shown so far, and still with no soldering, you can start to build a little more complex projects. Things like LED displays, various types of sensors, and even something like a breadboard version of my parking assistant. But at some point, you're probably going to need to make more permanent connections in some of your projects. And yes, that might mean a little bit of soldering, even if it's nothing more than learning to attach pin headers to a component. But don't give up. By adding just a couple of basic tools and learning a few basic soldering techniques, you'll be able to cover almost all situations for your more advanced projects. One option for making your connections a bit more secure is with hot glue. If you're using something like DuPont connectors, you can add a little hot glue to help keep the jumpers from easily falling or being pulled off. And since hot glue isn't electrically conductive, you don't have to worry about creating a short or inadvertent electrical connection. And it can be used in a lot of other ways to hold components in place within enclosures or even to manage wiring. But since it is not electrically conductive, unfortunately you cannot use it to make actual electrical connections. Make the most secure and permanent electrical connections, it does require learning to do a little bit of basic soldering, and it doesn't cost a fortune to get started. I bought my soldering iron nearly 5 years ago for less than $25 and it's still going strong. You add some appropriate solder, and then I always recommend a little flux, which comes in various forms like liquid or gel. One other tool you may wish to consider is some form of helping hands. As the name implies, it's an extra set of hands to help you hold your components while you solder. Many versions have a metal base and these magnetically attached arms that you can reconfigure in a variety of different ways to hold your various components. If If you can learn just a couple of basic techniques, it will probably cover 98% of your soldering needs for your DIY projects. There are many great tutorials here on YouTube on getting started with soldering. The best beginner tip I'll offer is to remember that you don't apply heat to the solder, but you heat up the components and apply solder to the heated parts. One of the most common things you will do, as I'm showing here, is through-hole soldering. This will allow you to do things like attach pins to your components that come without them pre-attached. It also allows you to install the pins in the best orientation for your project. Another little tip is to use a breadboard to hold your pins and keep them vertical when soldering on the component. The second technique is soldering two wires together. You may have projects where a bulky connector like a wire nut or a Wago lever nut just won't work. So learning how to solder wires together or solder a wire to a component will be another common technique that you're likely to use often. If you can learn just these couple of basic techniques, it will allow you to start taking your breadboard projects and moving them onto much more secure and permanent solutions such as this electro cookie or other kinds of prototype boards. Hopefully I've shown you how you can start out with absolutely no experience and no electronics or coding knowledge and begin to build your own projects. And as you gain some experience and add a few tools to your arsenal, you can actually begin to design and build your own complete DIY electronics projects. Not more than just a few years ago, I'd never built my own project. I'd never soldered before. I hadn't even heard of YAML before Home Assistant and had never written a line of Arduino C++. And don't forget, you can always find help along the way. The primary intent of my channel here is to try to help people get started with Home Assistant and DIY electronics projects, and I'm always happy to answer your questions to the best of my ability. And there are many other creators here on YouTube or places like Discord or online forums that are more than happy to help you out. I wish you all the best in your own DIY electronics journey, and as always, I'd like to say thank you for watching, and I hope to see you soon.